So, hello everyone. Today we are discussing the backtracking portion. So, the backtracking is one of the important algorithm. Many questions directly come from this topic. So, just heading as a backtracking algorithm. Okay, backtracking algorithm. So, in this we face in simply we have to do one things in backtracking: do, explore, and undo. And okay, so simply backtracking is based on only three concepts: do, explore, and undo. Okay. One of the standard problem. So standard problem based on backtracking is first is permutation permutation of permutation of a string. Okay, permutation of a string. Okay, that a knife tool is the high complexity knife tool problem. Knife knife tool problem in which eight direction is have to move in all eight direction. After that, rat in mesh, rat in mesh problem. After that, subset problems, all the subset problem, subset problem, standard problem, permutation, string, night problem, rat in mesh, subset problem, removal of invalid parenthesis on the removal of all valid parentheses. Okay, so these are the standard problem of the backtracking. So let's see one by one question. Permutation, night problem, rat image. So permutation problem. So, so simply the permutation problem is simple. In permutation problem, we simply in permutation problem or only and not full code. Simply simply write one of the basic example. Okay. So in permutation of the code, permutation problem, we simply returning all the permutation of the ABC string. ABC. So we have to ABC, ACB, BAC, BCA, CAB, and CBA. All these are just swapping the element, uh, again backtracking and undoing the process. So and simply we have the step are like this. So only I have to write these steps. I simply write these steps. So the, wait for a few seconds. So steps are as follow. Steps are as follow. So in this portion we have to what have to do. If we reach idx is equal to size as dot size. If we reach the element, so in this case we have to answer dot push answer push as okay and then return. So this is the base case condition. Okay. The for loop for the from idx till s dot size. Okay, s dot size. Okay, in this case we have to do swapping thing of what idx comma swapping between this, and backtracking portion will be done. Backtracking for the further idx plus one portion, and the undo the step. Simply swap once again idx comma I. So this is the simple step through which we achieve the solve the permutation problem. Okay. So after solving this, we have to discuss about the time complexity of this problem. So time complexity is simply the order of n, the size of this, and n factorial for the searching. Okay. Space complexity is order of n. We are not using only using the answer vector. So this will be simple. So we solve the problem of permutation. So we move forward for the next problem is problem based on um, night tour problem. Okay, night tour problem. So question number two. Question number two. The the NIGST night the your tour problem. So in night tour problem, given we are given with the n cross n chessboard, the knight started from the top left and corner 0 comma 0 and must visit the every cell exactly once, have to visit once exactly once, and a standard move for these two step in one direction and one step in perpendicular direction. So simply the moment of the knight is look like this: one step and move, two step up and right, simply in all direction, two step, one step. Okay, two step, one step perpendicular. Okay, two step, one step perpendicular, 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 two step, one step perpendicular. So how many we can see that there is eight direction, 1 2 3 4 5 6 7. So knight can move in all eight directions. So return the grid where each element contain and step. Okay, if there is no valid path, there is no valid to exist, so simply return d minus 1. So the we have n, so we have to return in how many steps they reach here. So in how many steps we reach here. So simply this is the portion, this one, this one line, this one, this one. Okay, this grid. Simply writing the grid. So we have to define. We are starting from the here, and how many steps we reach here, and how many steps we reach here. So one, two, one step, uh, two step. So one, two, three, and three steps we reach here. So you have simply return this step to reach all the section. Okay, let's see the approach. So each number represents the step at which the knight visit the cell, and starting from 0, 1 as a step 0, the output should show one valid tool for the all five players. So first of all, we have to solve this problem using recursion and backtracking. Okay, it take time complexity of 8 direction into n square, 8 direction in n square. So 8 in the power n square time complexity. So simply what we have to do, we will use recursion and backtracking to build a sequence of knight move that visit every cell once and start at a 0 comma 0, and each visited cell with the move number and try all 8 knight moves from the current cell. If move lead to the dead end, so undo the step and try for the next one. So stop when we place to the n square moves. Okay, when we are exhausted, so failure. So what are the steps? Simply we have to write the steps. So steps to solve this problem, steps to solve this problem. So step um, step 1b. Okay, So first step is to solve the problem. So write all the direction, all the directions we have, all the direction we have. So what are the directions we have? Simply mm, dx, dx a direction. So in which we have to write the all x coordinate. So 2, 2, 2, 2, and 1, 1. So movement of all the x direction movement, simply to write the dy of 8 direction we move. Direction is represented after that. We have to write and check and after that. So condition is, if first condition is that if the step is equal to n into n, this means that we have explored all the rows and columns. In this case we have to return true. Okay, okay. After that we try all 8 possible nights move. For example, we start from the for loop starting from 0 to here to here to the direction movement. Okay, a direction movement. Okay, or we create int nx is equal to the start the previous one with the d of dx of I, and and the new and new y direction is equal to new y direction is equal to previous one plus adding the new y direction. Okay, and after creating a new direction is check it is valid or not. So we are checking or valid or not. So we simply check if this condition is safe, अगर safe of अगर safe है nx or ny, nx and ny is safe, so we mark the board as a step. So we mark as a board of nx comma ny is equal to, with this we move the steps we are taken to reach here. So and if the true exists, if the night tour exists, if night or we also have to check if the night condition return true, so we return true. Okay, and undo this step, return true and backtrack board of nx plus ny. If we can't answer, then simply -1. Okay, so each safe condition was taken as each safe condition taken as. So how we check each safe condition? Each safe condition each safe condition is, how we check each safe condition? Simply we check if x greater than is equal to 0, yeah, and y is greater than is equal to 0, and and x is less than n. Okay, and y less than n. So in these cases all the conditions satisfy, and also we check the board. It's a board of x is equal to, if x comma y is equal to comma is equal to -1. So in this case we have to return true. In this case return true. Okay, this is the condition through which we have to return true. So this is the night route problem. Mm. So we cover, so after that we move forward for the next problem, rat image. Covering the permutation and night problem, we move forward for the question number 3 is rat image problem. Rat image problem. It's simple and generic question of the backtracking. So we are given with the square matrices. We are given a binary matrix of representing the image, and the rat start at the top left corner from 0, 0 and need to reach the bottom and one the last one. The rat can move in any four direction: up, down, left, right. Find all the possible paths from 0 to n minus 1. If multiple paths exist, return them in lexicographically order. Otherwise, if no paths exist, return empty list. So rat cannot in the same cell more than once. So rat cannot visit the cell more than once. One represent the open cell, zero represent the block cell. So we have to represent all the simply we have to represent the valid path. This is this is the this this one will exam. Okay, this is our source and this is our destination, and one of these represent as 1, 1, 1, 1 and 0, 0, 0. So the zero portion means that it's blocked. Okay, so how its rat move to reach the position of destination. So return the number of ways to return. Okay, we have to return how we move. If we move down, so we have written down. If we move right, so we have to write r. Move this portion down, right, down, right. How many times we return down, 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 right, and down, right to reach the destination. Okay, so let's try to figure out how how we think for this question. Simply thinking like we move here, go there. If there is a blockage, we return back to the original position. So this give me the idea of using the backtracking of algorithm. So let's see the approach of the let's see the approach. So steps steps using back backtracking approach. So okay, backtracking approach. Let's see. Mm, steps one. The idea is to explore all the possible paths from the source to destination. We recursively build each path, store it when the destination is reached, and the backtracking is to explore all the alternative routes to avoid revisiting the cells. So what you have to do? Simply first, the first idea common man, we take the size of the matrices and cross and so mat dot. So this we find the after that. Step 2, if we reach. If condition is if R reach n minus 1 and column is equal to n minus 1. N minus 1. In this case, we have to push back the path we explore. Okay, path we explore and and mark the cell as a visited. Marking the cell as marking the cell as visited. So row and column as a visited is equal to 0. So explore all the four directions down, left, right. Okay. So exploring all four directions. For explore 0 to 4 direction. So what are the four directions? So new new row will be older one plus new dx of 5. New column will be new column old one plus and new column. Okay. And after deciding the new row and new column, we have to check is it safe or not. So we have to check safe condition for the new column and new rows and new column. Okay, in the image. So if it return true, if it return true, we simply add path dot push back what push backing the dir of I dir of I. what what does it mean by dr of I? Okay, and explore for the backtrack no, explore for the path path. Okay, find path for the new row, new column in maze having the path and then the result portion. Okay, exploring and undoing the step. After that, we have to pop back path dot pop back what dir of I, through which we have to do the all the things, and after that we mark as visited. After that we mark as a maze of row and column as a visited one. Okay, mark column as a visited one. So the idea is how we define the directions. Okay, the two things we have to do, we add the directions. So at the top, okay, we have to define the directions. dir is equal to d. We have to define dlru, down, left, right, and for also explain the all four directions. For the all four direction, dr for the 4 is equal to 1 comma 0, 1 comma 0, then 0 minus 1, and new column for the 4, new column for the 4 all are written as 1 comma 0, 0 comma minus 1, 0 comma 1, and 0 comma minus 1 comma 0. So this is the action condition or safe condition boolean safe condition for the new rows, new column, maze, all things are given. If condition simply is like row is greater than is equal to return this is condition, row is greater than is equal to 0 and column is greater than is equal to 0. Simply row less than n and and column is less than is equal to n. One more condition that is image of row and column is not is equal to and is visited is equal to 1. So if it is 1, then we have unsafe condition, so we move. If it's not safe, so we can't move. This is the algorithm. Simply and defining the all direction, checking the safe condition, move if n is equal to n minus 1, push the result with the path, explore outward direction, check the safe condition, if safe, push the path. So after that we come to next problem. This is an important one, is the NQN problem. So how we solve the NQN problem? Let's see. So question number 4. Now 4 is the NQN problem. So after the turn of the night problem, we come to know about the NQN problem. In NQN problem, similarly, there is a chessboard of size of n. Place the n cross n chess such that no queen can attack each other. So queen can be attacked another if they are placed in same row, same column, or same diagonal. So queen attacking power. So how queen attack? So queen attack like this. Simply, if it is in row, if it is in column, or if it is in diagonal direction, we attack. The queen attack in all these directions. Okay. So find all possible distinct arrangement of the queen on a boards that satisfy these conditions. So output should be an array of solution where each solution represent the placement of the queen. placement of the queen. Okay, if no solution exists, return empty array. So when the task uh, is that to fill the task task is that to place place all four queen in the chessboard. So how in the four cross placing the four queen in 4 cross 4 matrix into 4 cross 4 matrix. Okay, how we place? So we check. We use first of all we use naive condition for backtracking. So idea is to simply backtracking for the n cross n chessboard. We proceed either by the row wise or column wise. For each row, try the placing the queen in every column and check if it is safe condition or not. Same for the all columns, row and diagonal. If safe, place the queen and move for the next row and column. If it validate condition, if not, backtrack to the previous one, try to different position and continue until all queen are placed in possible direction. Okay, so it's simply like it's simply like uh, placing the queen in row, column, and fixing the safe condition. After that, you have to check the safe condition. Is it safe or not? Safe or not? Or not? If safe, if safe or not? If it is safe, if it's safe. So we move forward for the next row, and in next row if we able to proceed, not safe. In next row, we are placing the at every condition. If not safe, so backtrack this condition. So in that case, backtrack. So backtrack once again and check the valid condition. So this will placing the n rows and columns safe or not. Place move for the next. If not safe, backtrack and we change the place and then the position of the queen. Okay. So what are the steps to solve using backtracking? So here is the n queen problem. Okay. Simply we use code section. So how we do? So first of all, we check the safe condition. Here is the only condition. Uh, we solve 3 or 4 questions in backtracking. We check the out of bound condition, but this time we have to check the safe condition for the placing the queen. Okay. In safe condition, we have given boolean. So all the safe condition comes with the boolean in which we have passed the matrix of the board. So okay, there is no problem. Okay, so after that we find the size of the matrix. So mat dot size, because it is a square matrix, so we don't need to find n on n. So initialize I and j for condition. So first of all, I run from zero to row. Okay, what is row? Mm, from the row, because in this mat and the row and column are given. Till the row. Okay, and if it is already check if there is a queen, if a row, if there is a queen on that column, if there is a queen already placed, if queen is already placed, we simply return 0, return 0. Okay, so we are checking in the we are firstly checking in the column of the upper side, Then after we check the uh, left diagonal. Mean the row start with row -1 and j is column -1. Row -1, column -1. So simply we move to upper upside direction. So how it's look? What's loop? We are checking our left diagonal. Left diagonal will be this one, left diagonal, right diagonal. For upper diagonal from the left side, in this we increasing the row in the left diagonal. So let's discuss. If we are checking in this direction, so we see that we see that the row decreasing and column decreasing. So we check if matrix of I or j is any given, return 0. After that we have to check for the upper right diagonal. So in that sense, and this row decreasing but column increasing. So row start with -1 to 0 and column start with the column start with the column plus 1, the column plus 1 from this portion, column plus 1 to the n. Okay, checking from the n direction. And if we return, if all these conditions satisfied, this means that the right diagonal, and if these three conditions are not there, so we have to return true. So what are the next steps? So if we if our row is equal to n, our row and column are given. If row is equal to n, so in this condition, if all the queen are placed, row is equal to n, if we place all the queen, so what we have to do, a vector in which we have to give the answer. So the answer will be in integer type. Okay, so until answer will be in integer type. Okay, so for looping, run for the all in row direction. So I is equal to less than n, 0 to 0 to n, and for the j, for and j also move from 0 to n. Okay, the rows and column are made. So after that, if condition, if mat of our matrix of I comma j is equal to is true, if true, we have to place answer dot push back what, j plus 1. We have to push the answer with the j plus 1, and at the end of this loop, at the end of the loop, we have to push all the result. So end of this for loop, we have to push rest dot push back the answer. Okay, push back result dot answer and then return. Okay, consider the row by placing on all columns, placing all inside the columns. So queen 0 to n, if safe mat row comma I, if is 1, so place the queen in next row and check. If it's not true, backtrack it. Okay, and queen placement, all we have solved the and queen column. Okay, after that we come to know about the subset problem, and queen is also a cross problem. So see the subset problem. Question number 4. Question number 4 5. Question number 5. Solve the subset sum. Subset sum problem. So in subset sum problem, given a set of a non-negative integer, we have to return the sum. The task is to print the subset of the given whose sum is equal to sum. So see how we make 3. Simply we have given the question that a set containing 1 comma 2 comma 1, and the our target is and the our target is 3. Okay, so target is 3. How we achieve the 3? So let's see, through 1 comma 2. Okay, through 2 comma 1. Okay, these two conditions through which we reach the target. So subset sum is like we are want to reach through this. Okay. Okay, the subset from problem using backtracking. Subset sum can also do a special type of 0 1 knapsack for the each of item. Include the current element include the current element in subset, or recursively find for the remaining one. Exclude the element and find for another. So so how we will solve this problem? So steps are as follow. First of condition, we are given uh, set of integer target. All things are given here. So if if all the things are given, boolean, print all elements in and set or target is given. So in void print sum, what is given through from which starting index, ending index, set of numbers, and the target. Okay, target, if our target sum becomes 0. If our target sum becomes 0, so we in this case we have to mark the flag as a 1, so we reach the solution and the solution, and we have to print the one subset of I. Okay, I know this. If I is equal to, if we reach and the end rate if we reach return if we reach the end of the array, if I is equal to n. So this case we have to simply return. Okay, or run the loop for what, if I plus 1 and simply and target sum or subset. Okay, or if set is equal to f of I, if run the loop, if set of I is less than is equal to target sum, then we add in subset. Okay, subset dot push back what set of I. Okay, move for the next question, move for the next index I plus 1. Okay, and set, and the target sum will be target sum minus set of I. Okay, so we pop back. Okay, and move for, if condition is true, move for the forward question. So simply adding, checking and pop backing things will happen here. So till now we cover the all basic and standard problem of the backtracking. So we move forward for the next question.